Good morning, and thank you for joining us for this session on AutoCAD Civil 3D and Surface Styles. And my name is Tench Tillman. I'm the president of Motor Competency, and there's my email address, which we'll give to you again. What's the jump all about? Well, we got a number of products, each and every one designed to help you make Civil 3D more productive in your daily life, so to speak. We have Instant On Basic, which is our basic seat product that includes about 1,800 styles and yada, 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 and makes Civil 3D run, work, publish right out of the box. We have this thing called Jump Kit. People go, I get a question this week. What the heck is Jump Kit? Well, there are 1,800 styles. You're not going to probably use everything that's in Instant On Basic, but you're going to find some things that, oh, well, maybe we need to just tweak things, and this, we need this and not that, and it's got to look this way and not that way. Well, the Jump Kit is our way of expressing that. It includes about 5,000 standardized styles, all compatible. You just drop them, build templates, build production templates to do certain kinds of work. Has, for example, things like 250 profile view styles. So if you don't like the way it is in Instant On Basic, the odds are 99% of it's been done already, and you really don't have to spend a lot of time and energy doing it. You can just root through the Jump Kit, find what you need, and go back to work instead of spend all the time messing with the styles. Simple Set, which is a piece, or the survey piece, if you will, of what's in the Jump Kit. And we even got a blocks only product. So if you got map users and AutoCAD users who just need the symbology that's NCS compliant and LDT compliant and AWPA compliant and all that kind of stuff, and and you want those people to be able to work, we have that product as well. The idea behind IOB is really simple. It allows you to work the same and then intelligently publish on demand. And those are really two different processes, and we tend to mucky them all up, and that makes us do stuff that's crazy and wastes a whole bunch of time and energy, at least in my opinion, and frustrates us and annoys us and causes us lots of problems. The idea here is really simple. Take nationally known standards that are clear, everybody understands what they are. We support multiple versions of Civil 3D, 10, 11, 12, and our 12 product, of course, on release day ran in 13. That's what we do. And, you know, we include all the parts, not just some of the parts, a complete structure and a process to help you get that all done. So we consider that that means that we have this unmatched price-performance ratio. Okay, so our total cost of ownership and maintenance of our product versus any other solution that you can do, even doing it yourself, by yourself, it's ridiculous. It basically costs you pennies a day to employ it and makes your life a lot easier. But if you insist on doing it your own way, be my guest. Okay, we're here to talk about surface style in Civil 3D. And we all know what surface style is. Come on, we've been using this stuff for years and years. If you've been in Civil 3D for a while, you pretty much get it. You got contours, you got stuff. So why are we going to talk about this fundamental thing? Well, each and every time Civil 3D comes out, because surface models and surface data is so critically important to everything we as civil engineers do on a daily basis, things change. So, and the fundamentals you may have stuck in your head, some stuff from our historic past. I mean, things look the same, but they aren't. And if you're coming from LDT, Eagle Point, AutoCAD, somewhere else, and Civil 3D is kind of new to you, there's a bizarre amount of complexity sat on top of this thing called a surface feature. And surface styles are a way of making that show up on our screen, and they can fool you. And how do we employ all this stuff? What is this idea of style, which is centered to how Civil 3D and, in fact, all model-based software works? How does it really work, and what are the stuff we got to deal with? So that's what we're going to try to bite off today. Next week we're going to do a webinar on how survey helps us express this. So taking survey data, getting it into a surface model, and all that stuff. So we're going to do that. So I'm going to try not to do too much of that. I'm going to have to do a little bit of it here, but we're really going to focus on what's going on with a surface style. What does it mean? How does it affect us? Before we do that, we really got to talk about style truth in Civil 3D. The styles, the label sets, the sets, which we employ all over the place, and including, partly, though they're not quite called that, inside of surface models, right? We don't use that language, but it's really going on. They are separate and independent from what we call the feature data, the real model that we produce. And that's really, really critical to understand. We mucky it up and it confuses us. So therefore, style, no matter what you got your surface looking like, it's always a temporary thing. Oh yeah, I know that, who cares? Well, the problem is it's so inbuilt and so intuitive most of the time that we kind of forget it. And so if things don't look quite right, well, I really don't like the way the contours are done. I think they should be on a different layer, so I can hop into the surface feature style and change the layers on, and now it's right as far as I'm concerned. Well, I actually contend that that kind of thinking, which is purely intuitive and is stuck inside of Civil 3D everywhere, edit this style, edit this style, edit this style, is the enemy of consistency, the enemy of sanity, and the enemy of actually a lot of productive work. It's much more important to understand how to run that process. That style changing skill is more important to actually your productive daily work. So it's really easy because it's so cool to make all these styles that do these cool things, but you know what? Nobody cares. Or may not care. You care because you ran into the problem. The next guy sitting next to you in the next cubicle, he may never care because he may never even know it existed. So the other issue is, aside from the feature styles, which are one whole set of things, and Civil 3D shows us that in the tool space, label styles can be also more or less problematic. They're less problematic because they have this thing called LSD, or label style defaults, and they obey a rigorous hierarchy model, which we really do hope actually happened elsewhere but doesn't in feature styles. But in label styles it does, and that's good news. So you can actually get, hey, my major contour labels all to obey a set of rules, and my minor contour labels, no matter what they look like, what layer they're going on, textiles and all that stuff, you can get them to obey rules because of the hierarchy, and so there's a lot less maintenance there. Label styles, even the simple ones that are plugged into surfaces at this point, do have a geometric structure, and simply put, the right arm is connected to the right shoulder instead of the foot. Okay, and that has an effect, and keeping those structures geometrically, how they're connected together, so to speak, can cause you issues, big ones. So if you don't do that correctly, the way the model expects, it'll look like it works in one drawing, and then when you put it in another drawing, they don't work at all. They also may employ this wonderful thing called expressions, which means we can put our own math, retweak the data, and express it in a different way. I would like the elevation shown both in metric and in imperial everywhere. Okay? So, for example, easy to do with an expression, but then if you don't handle the expressions right and how you move around and put them in your templates and all that, drive yourself nuts with that thing too. So those simple truths, right, are also backed by a couple of things that happened in 12. And these things really didn't change. I haven't been able to rigorously test everything completely yet. We're still going through that with a full release. Kind of came out quicker than we all thought it would. In 13, there's new style management tools, which you can, kind of bring the hammer down and fix things that other people have messed up, purge things you don't need so you're not handing out a whole bunch of unnecessary stuff to people and import styles and do that sort of stuff. Those tools are in there. Those tools are very useful. They do take some practice. You know, if you don't work on them and practice a little bit, when you finally do need them, they're almost useless because you don't know how they work and what the consequences of what you do are. So I always tell people, hey, even if you don't need this, you know, spend a little time here, because when you do need it, it's like recovering a drawing. I forgot how to do that. Oh, well, you have MAP. It's the best recovery tool in the world, but I haven't done that in 4 years. Well, sorry, you know, you got to do a little bit of preparation. There are also find and replace tools built into Civil 3D since 12, and they're there in 13, and they are really handy. Say thank you, Dench. It was my, you know, one wish that was fulfilled in 12. The style truths mean for us that in terms of things like surfaces, things like alignments, things like profiles, you know, once you get them QA'd and they're pretty good, you want to get them into what we call a no styles drawing in your project. And no styles literally means that the drawing contains only the styles name standard that Chip or AutoCAD Civil 3D actually makes, because it will make the primary styles it needs. And this is pretty easy. You take a raw AutoCAD template file in the new release and, you know, just fire it off inside Civil 3D and then save it, and that will make you a no styles drawing. It won't have anything you created. Now, why do you want to keep your features that have been QA'd and gone through this whole process in no styles? Pretty simple, not rocket science. When you upgrade your project, nothing you did is going to be in the way. And the problem is, you know, our madness, right? Software might not understand, and all of a sudden things are all chewed up, and things don't work, and things don't publish properly, etc., etc. Now, so storing your existing surface, your final proposed surface in these kind of drawings, right, get you over the problem of, well, you know, it didn't upgrade and it's your fault. Well, it really eliminates that probability, and actually you will find if you practice this religiously, your whole project will be cleaner and go up. And so in terms of real work, which is like, I need to upgrade this project because it would really be handy to have, you know, alignments that stayed geometrically connected by rule. For example, bing, right? It will make that process easier. And I also say, since we're at the forefront of a new release, we have customers who are in 12 and, you know, upgrading and thinking about upgrading their stuff to 13. And, you know, I'll be people who bought it the last week because it runs in 13, and okay, now I need to do some other stuff. Great. Hallelujah. But you need to keep this idea of a project that's separate from your real projects, where you make sure you test, work through all that stuff. And I've covered that kind of stuff in webinars, you know, lots of videos, right, elsewhere. But it's the first thing you got to do, okay, because you got to. And, you know, we want to have simple templates, you know, and adding styles into this or more complex into this stuff. You got to start from a known place, keep that known place good, and then improve more Civil 3D users in the organization, and more individual responsibility and accountability to say, hey, this is a company project, it's going to work all the time. You could build for 1,000 years and you will never answer that question. So you either say your people can have the skill and be responsible and do the work that must be done, or you can pretend otherwise. Okay. So in terms of surface styles, these are the kind of points we're going to make inside what we're going to our route through in Civil 3D. And I will make the contention that a published style, contours at 1s and 10s or 2s and 5s or whatever you want to do, are not what we call a QA style. And unequivocally, whether you believe it or not or think this is true, the data isn't exactly what we are really publishing. We are publishing a representation of it, and that's what style does. And there are layers of this stuff, even with something as simple as a surface file in Civil 3D. There's layers of stuff going on behind the scenes that all happen magically and really quickly, and, you know, when it works, it's great. When it doesn't work, what the hey, you know? And like I said, it can fool you. It can fool us. So I think we need to focus on what we call the purpose before we get into the detail. And I think this kind of falls into terms of surfaces, three basic pieces. And they are kind of separate, and they have their own little teeny loops in there. The analysis of the data that's going in. Now, whether the data is existing data or proposed data, you better make sure that what you throw into the blender, right, is the right stuff. That if, you know, it's not salt when you're supposed to add sugar. And that's easy to do, and styles help you see the difference. You know, do you want zero elevation shots in there? All that kind of stuff. So there is so much data in a resolved surface model of many, many complex surfaces that you've got to kind of compartmentalize the process. Look at the bits and pieces, because you may be trying to fix fundamental data problems that have existed for a long time and you only just noticed now when you went to print. I always give the classic example of, did a 25-acre shopping center site design one time, and as we're printing the final go-to-build set of prints, look down and the datum is off. The datum is off by 6 inches. Now, 6 inches doesn't sound like a lot, but it's a tragic consequence when you're pulling out, you know, 100 truckloads of dirt and making a 40-acre shopping center site actually a lake instead of slightly above grade. So stuff goes off of it. And it's really easy to miss that stuff. Obviously, lots of people checked. City checked. Engineers checked. Multiple technicians checked. And nobody caught it. And boom, luckily it got caught. All got fixed, right? And, you know, the shopping center got built in the right place. And probably if it had gone out to construction, you know, some surveyor would have gone, some guy doing stakeout would have gone, something's wrong here. You know, but maybe not, as we all know. The other part is that while we go through the process of building, massaging, doing what we need to do with the surface, there's an in-process evaluation of that. And then there's the process results themselves. And those may seem like the same thing. In some respects, maybe they are, but I don't think so. And you can use different style, in other words, to do this and look at it differently. And that's one of the great things that style gives us. And then, of course, the published finished result deliverable. Is that, you know, going to be a PDF, or is that going to be, you know, effectively end up being AutoCAD polylines at elevation as a digital deliverable that's might end up in a city base map at some point. So I believe that the quality assurance styles, right, are the most important thing. And I call this visualization in time, or visualization in 4D, which expresses the three things above there. And this occurs inside your standard practice, inside the workflow of building a surface. And they're there to help you check the data source complexity and reduce the interaction complexity. So I hope those things make a little bit of sense. Now that I've flapped my lips about it, let's kind of look at Civil 3D and kind of see that happen a bit. In 13, just gotta clear my spaces here a little bit. You know, raw 13 out of the box. Hey, please do me a full screen here. And you know, this is the NCS template that ships with Civil 3D. So, you know, you're gonna have, you know, a small little selection of point styles, and basically one of everything else here, right? Is it NCS compliant? No, not really. Is it sort of NCS compliant? Yeah, maybe. Depends upon how you tear it apart. But you really couldn't produce a plan set out of this. Everybody knows that. So, have at, make your own template, and make your own styles, and go for it. Other choice is to use something like IOB. And IOB runs on this idea of, you're going to have a project, and I'm just going to, I got a project-based profile here, and so when I hit this little button here, I'm actually changing where my templates are pointing, and that's pretty much just about it. Okay, but now instead of pointing off into where Civil 3D installed stuff, I'm pointing all my data resources and all that stuff into one place. And I did change my screen color. I just find this records better. I actually prefer to work on white now, so I've kind of rechanged my brain to, instead of working on black. I made a couple other little minor profile things, but try to not do all kinds of stuff. And what we're going to do is, figured we'd show you a little bit, one of the cooler things here. I've got my template location changed, so I need to refresh this. Here's the 12 template. Here's basically that 12 template upgraded to 13, and we're just going to create a new drawing. With that template, and it's got lots and lots of styles. We're going to focus on the surface styles here and some Civil 3D 13 things. One of the notice things, if you even load this thing up first, to get rid of that drawing so I don't go back there by accident, I've got to save this thing. But before I do that, a couple of little drawing settings things. For those of you who really haven't looked at 13, you got some new things pertinent to, okay, and that kind of stuff, right? For pressure pipe networks, a few other little subtle changes here. This list pretty much says, okay, where do you want the feature stuff to go, and the style controls everything else. So it is possible to simply throw all this stuff on layer 0. That actually works, but that will mean that you spend a whole much more time in the layer manager. This basically is, do you want your surfaces on this layer or that layer in terms of that, in terms of where the feature data itself is kind of stored, though the feature data really never is on a layer in the way that we think about it. So got a new few things in there. We're going to work in our standard project, example project. Oops, not 2 eyes, 1 eye. Here you go. That the jump project happens to be done in, right? So we're in the right coordinate system because all the data is in a coordinate system. That helps us talk and use and do all those kinds of things like use aerial photos and all that stuff. And then we got to save this thing, and we're going to save it. No, not in my documents. No location, inside my project, inside my 13. We're going to go down to existing conditions. We use an NCS-like model structure tweaked to work like Civil 3D. We're going to build the surface model in here. I got a 10. I'm just going to make an 11 here. And we're making an existing one just to keep things simple. Things get a little more complicated when we're talking about, proposed, obviously. And we're going to throw some data in here. And instantly, now we've got what we did before. Okay, I need some points. So, how do I insert points? Well, I remember I've been using Civil 3D for a while, so, we can go to point creation tools. There are other places to get to this, and I want to import a point file. Okay, and I go, what are you doing? Nothing wrong with this method, except for now you're creating potentially 2,000 more features in your drawing that are going to have to be referenced by another feature. Oh, wait a minute. Okay, there are other ways to deal with this. They've existed all the way back to the LDT time. So, we really need to, go to our prospector, and we're just going to create a surface here. And pretty much you've got to give it a name. This is probably the most important thing you ever do to your surface. We're just going to call it 11EG because I already have a 10 and an incrementing here. Okay, and it's going to have some sort of surface style. Well, doing this contours makes me feel good and it's familiar, but not really useful. I'd much rather have it do, borders, triangles, and points, and I'll explain why in a second, and say okay. And so now I got some data. I'm a smart guy here. I know that's in my data definition. And so instead of a point, I get point groups. I also have this idea of a point file. So if it will create points, odds are, it will also, feed your surface. And what we're looking for is a PNEZD file. Okay. And it's in my project location, and haven't been there before, which is why I got to go through all this. And down in surveyors made some point files for me. Oh, well, there's nothing in there. Oh, well, that's not true. It's looking for TXT files. They happen to be CSV files, and they're two sets. One came from the aerial photogrammetrist, point shots. Other came from stuff survey people collected. So I'm going to throw both of these in. Okay. A couple of things QA-wise. No, let's just start with the aerial points to start out with. Okay, so have these been QA, or was the datum done between these two existing point styles? Well, my process here is that if it isn't there, it isn't going to be in a folder that I can get to on the design side or even on the survey side. If it ain't checked, I can't put it into surfaces, right? So hops in there, and there are a couple of subtle little things going on here. And if you don't know what these checkboxes mean, don't employ them. Okay, by default, this one is checked. Okay, do you know what's going to happen? Well, the help file will answer what will happen and what Civil 3D is algorithmically going to do to your data. Okay, but if you don't know what they do, please don't do it, or go find out why, which would be a good idea. So, Civil 3D since 12 has this nice thing. It knows, oh, that's a PNEZ file. There's the northing, the easting, gives you a little picture of what it is, right? Tells you what the raw description is. And really our surface model at this point is going to refer to this data file just like an XREF. Okay, and so if this file changes, we resave this and update this stuff, will our surface model update itself? Yes and no. Okay, so now it says paint, got all my points, right? Okay, and there are 2 points in the same location, and this is just a fast way to get to my surface model, right? Okay, so in both files there was a common point, and it better be if, and there probably, one of my questions right away was how come there weren't like 5 or 6 common points between what the surveyors went out and got, and at least the crosses should be there. But well, maybe we thinned all that out. And so we get a classic 10 model. This is a great way to visualize what's going on. I can, check, okay, so this is all pure point data. There's nothing else in here but point data. I'm looking at some things right away. One, first thing is what's going on around the edges. Well, one of the cool 13 things is we have a new build property. Okay, so if we go up to our surface properties, right, we got a definition, and we have these build properties, which in Civil 3D, instead of giving you yes, yes, yes answers like they did in LDT in the old days, they now kind of throw them in there by default. And there are some things going on in here in terms of what's the default. And one of the subtle things in 13 is they changed some of these in the default. Okay, so you might go check, right, if your surfaces suddenly do slightly different things when you build new ones in 13. Some of these in the default template at least seem to appear to me to somebody went through and changed them. I don't know that it was intentional either. Okay, so you can exclude elevations in here, include elevations, right? This is a classic one. Copy, deleted, dependent objects. What the heck? Okay, and once again, these are all, explained in some form, arcane form of explanation programmatically, right, in the help file, right? And at least reading that stuff might help you a little bit. But there is a new one in 13, and it's called Use Maximum Angle. And so we're going to use this here, and we're going to leave it at 90 degrees, which effectively means it's going to march around the perimeter, and this is a perimeter-based thing, and it's going to, if the maximum angle between the adjacent tin lines, right, is greater than, and this value can vary between 0 and 180, right, so as you swing and it finds one and it looks the other and it compares the two, and if it's, less than this angle difference here, throw it out, and what that ends up doing algorithmically, and because I applied it, it's going to rebuild my surface, and we'll see in the background all the edges, all the L-type edges, right, pretty much disappear all the time. Okay? And, if we do something really crazy, like make this 45 degrees instead, okay, it's going to reprocess, when I apply, I rebuild the whole thing, it'll reprocess. Oh my goodness, so it can actually chew into your surface. Okay, so how about if we go back to 90 here and hit apply? We'll go back to where we are. If I made this like 120 degrees, okay, apply, rebuild the surface, you'll end up with more that survive. Okay, all right, so I found basically the way this algorithm appears to work somewhere between 120 and 75, depending upon the condition of the data, and slightly more than 90 works usually a little better and get a better result, but we all have to play with that. You can, of course, say, no, what the heck, I want to do this manually, like I've done before, hit apply, rebuild my surface. And so part of my point here is that as we're evaluating our point data, which is what we're doing, we're building a surface, taking a look at it, seeing how it's interconnected, and this visual straight up and down plan view representation of quick view, right, effectively what we used to call quick view in LDT, gives us a relatively good picture of what's going on with the surface, and now we can play with build, right? And of course, inside build, there's some other things here. Is, do you want to use a boundary? Do you want to use break lines? Well, I'm not using any of these things right now. Right? Okay, so one of my little wishes for Civil 3D is that I could grab all these and say no, right? But I can't do this. I have to pick one at a time and change each one. I'd like to change all these build properties, and no, I want to make sure that I'm not actually sucking in some stupid AutoCAD line into my surface model. Okay, so this is what I mean, and this is what I meant by employing the build data operations to thin out the data. So I can feed 1,000 break lines into my surface here and say, please don't do those in the, please do not use them now. I can feel, put in, stuff from the USGS's contour data, right? And say, no, please don't use that now on my surface, and still look at what my surveyors did, what my aerial people did, without any of that stuff getting in the way. So this is a way of, again, analyzing the data. And I employ both the build operation and my style to do that. Okay, I'm going to get out of build box in 13, right? This little interface gets a lot more usable on everybody's machine with the same hardware, because the new DWG engine in 13 is faster at visual style stuff, and that's good news. I'm going to still use the object viewer, which kind of short hops the same thing, even though I probably don't need to as much, but I just have a tendency to do this. Okay, and because it expresses in a much more simplified form a bunch of things about Civil 3D and how style works in here, right? In a fairly coherent way, I think that helps people understand what's going on. So, first primary thing is, where's your camera? So actually this, where's your view, right? So we'll go southeast isometric. All features in Civil 3D, all object-based features. AutoCAD doesn't draw these pictures. The features actually say, this is what I'm supposed to look like when the camera is here, there, or otherwhere. And they're, specific conditions like, pure top, right? Okay, and there's always a camera inside AutoCAD. The features know where the camera is, how they're being looked at. So, I used to joke they're like Pretty Women. They always know how they're being looked at and dress accordingly. Nothing sexist about that remark, just something human, I think. Okay, so if we go lefts and rights here, and my current style's got skirts, that doesn't actually necessarily help me. What do you mean, Tench? Well, I can't tell if I've got a big hole in my surface, if I've got these skirts inside my style, right, that's what it's feeding me. The style is saying, have the skirts on and show this. Well, that doesn't necessarily really help me. Okay, so, now I gotta go and fix the style so it doesn't do this, so I can actually see if I've got some big nasty blown point here. Okay, I got some other ways over in the definition box to look at the data and those sorts of things that will give me a heads up on that stuff, but I just want to point out right now, I go, well, I just want to see if there's some death hole in here, or, there's obviously no up spikes, but because I have skirts turned on in this style, right, I can't see them. Well, that's dumb, right? Once again, so we got this view-based thing, and then we got this visual style thing that is always sitting there too, right? So, we can go shade it with edges here, okay? And AutoCAD is now expressing the style itself. I'm going to move the camera around and we're going to zoom in here in a totally different way. So we got layers of this. There isn't just one view, right? As AutoCAD has evolved, the Civil 3D has evolved, we now have these multiple interactions or visual ways of looking at our data that can be extremely helpful, but can also deceive you, right? All right, so, and of course, all this is now intuitive, high speed in terms of rotating things around and zooming and panning and all that kind of stuff, right? All of which says, what the hey is going on here? Is there really a bunch of little bumps out of my surface? Okay, now I see there are bumps out there, piles of dirt. Okay, I got some funny little stuff going down here. What the hey is that? Okay. Like, what the hey is this? Oh, okay, so I got some little mini cliffs going on here, right? And remember, this is pure point data. I have no features, okay? No figure, no break lines, no faults. Pure point data, proximity based, okay? And I haven't massaged it in any way, shape, or form. Also, my style shows me where, hey, my data points are, okay? And does some things like, I got this big huge area with no points at all. What the hell is going on there? Now, I happen to know there's a building pad here, and this is a big huge building, and so is there a hole in the surface or a level floor? Yeah, sort of depends, right, on if you're going to have to build something there. So, inside the object viewer, we get a picture of, these are tools, all of them there to help us look at stuff, right? There to help it, make it easier for us to make good, valuable, useful decisions, and maybe even show somebody else what the heck is going on, so we're not confused. Civil 3D style, cute. What do you know? This is actually the first time Civil 3D has actually crashed in RTM. I don't know what I did. Okay, go away, right? So I'll leave it to you, trying to show something and not wasting all our time. And we're going to bring that back up, and we'll be back up in just a whole second. Oh. Let's see if anybody's got a question while we let Civil 3D start. Nope. Anybody learn anything this morning so far? No. Yeah, cool. Close that little boxy. Okay. Oh, he said, somebody said, what the heck are the skirts thing? Okay, we'll talk about that. I was getting there, actually. Okay, back to where we were. And we save that drawing? Yeah, we saved that drawing somewhere. And it probably doesn't have my points in it, my point files in it. But is it enough to look back? Or you think I didn't save it with the point in my surface? But we can get back there and shake some scale. Yeah. So we're going to create a surface. Well, once again, we're going to incrementally number this thing. And I would probably say, hey, evaluate point stuff. And what style did we pick? Pick that triangles, pores, and points. And we're going to say, okay. And we need to feed the beast here. I need to feed the beast some data. And we did that via point files. Okay. And this way, my simple reason for this is no point features. Comma delimited. Okay. And say okay. And we'll grab both those and throw those guys in here. Processes it, finds it, not doing elevation adjustment, got mutual points, and I cheated by zooming to it. Oh, where was that? Oh yeah, that was over here. Okay, so no zoom extents and all that jazz. And somebody asked where this is a style. It's expressed, right, as a style. And of course, because it's Civil 3D, you can always right click and edit the surface style, right? And go at it this way, and you'll see this is Porter's points. And then over in the display tab, every single 3D feature has lots and lots and lots of stuff in it. Okay? And we can put in the layers, moving here. As notice, to view directions, right? Okay, and this is actually what's called the display system, right? And Civil 3D sheets, and we're going to have plan view, profile views. Maybe notice surfaces don't have a profile view, but that didn't. But they got a section view, and they have model view, which covers what's going to happen in any other view other than straight up and down plan or section. Okay. And so in this view, I have the points on, the triangles on, and the border on. Okay, so I have the border on in my 3D view all in place, and that's the skirt. And it actually goes from 0 to okay. It's a completely separate thing from the 2D border that you see in plan. Okay, so we got a border that runs around the outside. We saw that thing, and that's that little yellow line. It actually goes down all the way down to 0. And I'm gonna edit the style. Oh no. Okay, and so I'm gonna turn that border off. Hit apply since we saw it the other way. Inside my QA border with triangles and points, I'm gonna turn it off. Okay, and now the border still shows, right? And once again, we're going to use the object viewer unless this blows up every single time, which it didn't used to. And we're going to do front from the front. Okay, so now you see I have no skirt. Okay, referred to typically that turning off the border in model turns off this skirt thing. So really, I was just seeing thing, and this is now all as I go around. Spin through. Notice I'm spinning through all those views, right? Okay, so quick and dirty, right? Yeah, probably don't want to be on the bottom. Okay, and hopefully you won't die. Good. All right. Okay, so the simplest and most basic QA style, right, is looking at the surface model itself. Now we're looking at a model built with a certain set of components, right, that just happen to be those things. Let's add some more stuff, right? And we can all add things into the surface model. We can add break lines, we can add contours and all that stuff. And I'm going to do that. I'm not going to do that because you don't know how to do this. I'm simply going to do it because I need some things to show the purposes of why you would need some other kind of styles. So one of the typical kind of things you might want is a bunch of contour data. And what's it going to ask for here? All right. Okay. Contour data, inside the surface model is really a combination of point data and breakline data. There ain't really no such thing as contour data that's separate. Surface models, by definition, have only two kinds of data. They have breakline data and point data. And point data always wins. All right, so when we're talking about adding contour data, it actually processes our polygons, which we don't have in our drawing, so we're going to have to find some way to get it in there. If we wanted to add contour data, and we wanted to add it into our surface model, it's going to process it twice. It's going to process it once as pure points at every single node that it discovers, okay, and then it's going to add break lines in between all those points. So it's really just doing the points first and adding break lines that follow along those within a certain set of rules. That's what contour data is. Well, we actually need an AutoCAD object, okay, to do it that way. How am I going to get stuff in here? Well, there's a whole bunch of ways to get stuff in here. I'm going to use, the classic method. I got a bunch of AutoCAD stuff. It's a drawing, and I happen to know it's in my data set here, and Photogrammetrist gave me a bunch of stuff somewhere, and it's in a drawing that he supplied to me. And notice I am inserting this whole thing. Of course, this is dumb. I don't want all the other stuff he put in here to create his surface model drawing. I just want his contour data out of that. And there are easy ways to do that. I can do a map query and reach over inside that drawing and just pull a copy of those out. Once again, I'm going to simply use the insert, locate, happens to be in the same coordinate system because that's what I demanded he do, and I'm going to explode it. And why am I exploding it? Because I don't want double copies, I don't want the block itself, I just want the AutoCAD CRUD. And this is all going to go and mess up my drawing and fill up my drawing with a whole bunch of AutoCAD crud and a whole bunch of his layer names and all that stuff I probably didn't want. But I'm not here to teach you how to do a map query to say I only want the contour stuff. Right, today. We've done that many, many times before, right? But I would have typically done this with a map query and just didn't feel like doing it. Now, so to do our contours, we need a selection set of those 3 polygons. So I can grab one of these and, see all of my nodes here, right? If I look at my property box, you'll find this is a certain kind of polyline. There being 3 kinds of polylines in AutoCAD now. And I'd use the select similar pick, and that gets most, but notice that there are these other contour things, which are 2D polylines. These other things are lightweight polylines, by the way. So I need to take those, and I have Shift Pad on. Okay, so I can grab one of those and select, you just can't pick twice. So let's pick both of them and right click and click select similar. Okay, so I happen to get 2 of the same kinds. Shift add, pick that, and notice I can do that, and I can go, wait a minute, I want the select similar. So interface wise, grab one of those, and now right click. Oops, hit the shift key on. Don't do that. Okay, grab one of those, grab one of those, grab one of these, right click, no shift key, select similar. Got all the little green lines, so I got all my contours in a selection set. A couple of easier ways to do that too. Right? Okay, so quick select. Right, might be a little faster, a little less harassing, and I'm going to add that data, and we're just going to give it a name that makes sense. Contours, and maybe even I want to, from aerials, because that's where it came from. These are not contours I made, right? They came from somebody else, some other surface engine maybe. And first time I do this, am I going to weed all this stuff and thin all this stuff? Well, if I told, my aerial spec was, do everything into basically 25 feet, so I'm going to make that 24 feet, and I'm going to supplement everything at 25 feet. That's what I asked for in terms of the data. Once again, these are build properties here. Am I doing all these other little things? Right? Okay. Once again, we're going to use our styles and things like that to evaluate the results of not doing those. At some point, you're going to figure, oh, okay, this stuff works fine 99% of the time, and I get a better result by doing it this way and applying that checkbox, not this checkbox, right? And hey, I'm happy. Now you may get a different set of data where swapping the edges may be the worst thing you possibly did to the data. So, gotta learn what they do, test what they do, and the style and visual styles help you do that sort of thing. So now we got a lot more triangles, a lot more density. You'll notice also that they almost get grid-like here because of my weeding factor and my supplementing factor were very close to one another, and that's what my data spec was, 25 feet. That's what I told my guys to go out and shoot station, right? Okay, so they either shot 150-foot or 25-foot stations when they shot stuff. I told my photogrammetrist that's the level of detail I wanted for him to do field shots and supply me this data, and I ended up with that big pile of stuff. And by the way, I hate bringing up this box, the layer properties box, right? Because I did that massive insert here, right? Amongst all my nice NCS conforming layers, I have, his crud. Okay, and how about if we, he's got data, EOP, sidewalks, building, top, back, curb, contours. Okay, we're going to freeze that contour layer. Okay, and we certainly don't want to see the stuff, and I'm going to freeze that contour layer. Right, and leave here. Okay, and how about, what happens if we do notice I didn't have rebuild automatic or rebuild now. Okay, so the AutoCAD data existed. I froze it, and right now I got a bunch of break line errors that show up. Right, all of a sudden, notice view, right, newest first. Okay, so now it didn't have me all these before, but now I have break lines, or what is this error saying? Oh, okay, so those are duplicates, so the contours happen to cross over where, I had point data. That makes sense. Okay, and so, I got these little minor errors in the right places. But my surface model is now detached from the AutoCAD stuff that came in. So let's go back, turn on my thing, and where was that? In the middle E, there's my contours. They're now frozen. Okay, we'll thaw them. I could turn it off. How about if I delete those things, right? We got a great idea. Let's get rid of that AutoCAD stuff so it's now we don't need that stuff. And is there any easy way to do that? Of course, we bring up the property box, find the quick select box and say I want everything in my drawing that's a 2D polyline. Well, actually we can do it by layer. We want everything in my drawing. I want multiple things, and no, I can't do that. Okay, so I want all the 2D polylines, right, on a layer, and that layer was, what was that? His EDAT layer, right? Okay, and EDAT contours, including the new selection set. Say okay, get rid of all those, and what do? They're selected. Okay, so I hit delete, they go away. Okay, and we're going to repeat that process. And what was the other kind of thing they were? 2D polylines. I don't want to get rid of the 3D ones. And they do have to be, also on a layer. And that was the right layer. And include that. Okay, and there's all those. And hit delete and get rid of those. And oh, wait a minute. It says the data that sits underneath my surface changed. So now when I do a rebuild, all my contour data disappears. Oh, not at all what I wanted to do. Okay, so get rid of those two erases and the quick select. Okay, and do a rebuild. By the way, if you want to keep your Civil 3D, probably want to do a save here. Okay, we also, right, so AutoCAD Civil 3D actually employs the real AutoCAD objects, right, to process once they enter the surface model that way. So break lines work this way, contours work this way, right? My point files are an external source, but the contours and all those kinds of other data employ real AutoCAD stuff. So getting them in the right place, keeping there, and making sure people don't just inadvertently erase stuff, right, is got to be part of your QA process. But we're here talking about styles, and we can grab, we can grab our surface model here, and change its style, right? And we got lots of choices. There is a much faster way to do this. We can turn on the quick properties box, right? And so when I select right? My quick properties box goes up, and I can look at this in different ways. I want this with, contours, 1s and 5s with, not slope arrows. I'm going to, yeah, I'll take 1s and 5s, and with slope arrows. And did that, and now I pick out here, and stuff goes away because got my stuff things. And now I got these little arrows that, based on their color, tell me, what's going on. And I can actually see that, I got, particularly on my streets, if I was looking at it this way, I got stuff running, but there is obviously no curb, right? And how do I know that? How do you know that? Well, because I can see that there is no dark colored arrows, right, running across my curbs. And so, therefore, right, I have no brake lines. And of course, I knew I had no brake lines before, but this is a classic example of a visual style that, in a very simple way, just by employing arrows that are in some graded color map, right? Do that. Now, of course, grab the contours, and that's a different thing than the slope arrows, right? We got other ones, right? We can actually, contours with directions and arrows, right? Okay. And let's go, why is the directions thing useful? Well, it is actually pretty useful. It could be more useful, I think, if they change the style in a couple of sneaky ways, but it will show you which direction the planes in that pin model at the same time as the arrows with your contours, and basically it's showing you in which compass direction, this happens to be quantified in 8ths around, so you get a different color, you get a different view. Okay, and this is particularly useful if you're studying road type stuff where the slopes are going to be, to the north, to the east, to the west, right, or increments thereof. I have one client who actually uses it to do topological evaluation for how to plow the roads, and uses it as an analytic tool to do that. And notice I got arrows that are different. Yes, you have a lot of style diversity here, so I can use open arrows, right? And of course, use different color gradients to make this clear. And so I wanted to apply this. You got to think about what's going on, and therefore you might avoid it. That doesn't mean it's not useful. You got to think about it differently. And because you think about it differently, you may find problems in your surface that you would miss otherwise. Now, we're about an hour in here. I've been told you all learned something. We certainly learned about the skirts, right? I want to grab my surface again here and, go to my properties, right? Nope, that's not what I want to do. What I want to do is grab my skirt, grab my surface, and edit my surface style, and talk about a couple of the other components in here, right? A surface model actually doesn't have, you might go, wow, that's a lot of components, but relative to some other styles in Civil 3D, there's hardly any. And notice in plan here, so we're getting major contours only. Okay, no minor contours at all. We're getting a skirt border, no points, right? And then, only one slope arrows, right, are being shown, and directions are being shown. Both directions and slope arrows are all going to layer 0 by default. They're white. How come they're colored? Okay, that's because the analysis portion here is controlling, what's going on, right? Okay, and this is very common in the analysis stuff in Civil 3D. We have a whole separate little calculation engine that is being applied to the style before it ever shows you what you had. So you got AutoCAD's visual style, you got Civil 3D style, and then you got this direction style, right, that has, a specific set of a way of approaching it. Notice these are all 2D solids, not 3D, right? Faces or hatches, and all of those might give you a better visual cue than this one, right? So QA styles inside surfaces are there to help you look at your data problem in a different way. And Civil 3D has got this multi-layered approach to how it's showing it and what, how it's changing what your eyes see. Unfortunately, it would be nice if you could just say, oh, there's just one thing doing this. But our advantage is there isn't one thing. There are three things. Okay, so I have Civil 3D style, and I got 2D wireframe on here. If I make this realistic now, right? AutoCAD itself, which is down underneath Civil 3D, is not even getting, but my background changes. Why did my background change? Okay, so Civil 3D is doing multiple things, and there are some things that basically Civil 3D is not employing in terms of what we're talking about here, right? And visual style is one of them that, for the most part, it's ignoring. But it can't ignore, for example, where the camera was, right? Okay? And of course, because I clicked a couple of times and didn't wait for things to finish, right? Well, okay, Civil 3D, go back to sleep. Okay, I want to hop back over here, kind of review this one more time, and let you all go. In terms of surface styles, we tend to think of the only reason we're going to build the style is this is what we want somebody to look at it, and that's simply a waste of what styles do in general. But believe me, I know a lot of people, that's all they want, because that's all they think they need to do. And I believe that you gotta focus on the purpose. Why are you making this style before you get down to the nitty-gritties of the details? Do you need this as 3D faces or 2D solids? First, you gotta understand why you would have a style that employs directions and what that is telling you. Okay. I also argue real clearly that quality assurance styles are probably the most important styles we have to deal with a lot of features, and surfaces just happen to be one of them that just makes this so obvious. If you've got a big huge hole in your surface and the only way you find it is because you've got lots and lots of contours and they make a little black dot, you probably are missing a whole bunch of things that Civil 3D can speed up, right? And because we were rooting around in all little bits and pieces here a little bit today, in terms of just simply changing the style 5 times really quickly and knowing in general what those styles are going to show you and what to look for when they come up, right? In other words, that idea that changing the style, changing it, is more productive than getting down into the weeds and messing with it, right? Is probably one of the most important things. You need to do things that instantly trigger, oh, when I look at it this way, bang, and that stuff jumps out at you. And that's an experience thing. It also says you have to have a consistent set of styles to do that. Hopefully this all helped y'all. Hopefully you learned a little bit. Thank you for spending time with me, and we'll see you next time when we'll root in a little bit more of 13 and look into survey queries out of data and building surfaces inside 13 with survey data, which is actually even smarter than the method that we used here today.